Counting slope on a graph. When you were writing your equations for the arithmetic sequences that we did recently, you were actually doing what was called counting slope. And what you did when you had your line on your graph, you found the starting point and you wrote the number for the starting point here. And you would actually, you were saying that my starting point was 1. You said that your term equaled the starting point of 1. And the line went up, so we were counting. And how much did we count to go from here to there? We would count 2. And if we wanted to continue to find dots on this line and count the next numbers, we said we'd have to put an n to tell us how many times to count 2. This was the equation work you were doing. Well, this number right here, the 2, actually does have a name, and it's called slope. That is actually the slope of the line. Well, slope is how the line moves. So in your equation, you have your starting point plus how the line moves, and n is the number of times you count it. Well, what I want you to take some time to do now is just practice counting slope. There are some different situations that you'll run into. One of them is just what you've been doing. You have a starting point where the line crosses our y-axis, which is our up and down line. Our x-axis is our line that goes across. Start at your starting point. We're going to go over one space, and how high do we go up? How high do we go up to get over one space? So on this line, we say I have a slope, m, equals, and I start at my starting point and I count. Looks like as I go up I go up 2 to get to the next time where it crosses a nice intersection, and I say I went up 2 over 1. So I went up 2 over 1, so then we counted 2, up 2 spaces over 1 space. So our slope again is how much do we go up, how much then do we go to the right, or how much do we go down, and how much do we go to the right. So this line here has a slope of 2. Let's take a look at our next one. Next one is a line that's actually going down. So if I start here, my starting point right here, and I count, let's see, we're going to find our slope of m and move, how the line moves. So I start here, and I look and I say, okay, I'm going down. I count 1 space, 2, and I count 3. So this is a down or -3. And it goes, how many spaces did we go over? How many lines do we go between? We went between 2 lines, so I have 1 space. So down 1, 2, 3 spaces, over 1. And I then have a slope of -3, because -3 divided by 1 equals -3. M for movement. The top is going to be how much we go up or down. Bottom is how much we go to the right. All right, let's take a look at another line. Now this line doesn't have a spot where it crosses on a nice intersection for us. So what do we have to do? You have to find the 2 spots on the line. So you look at the line, and where does the line cross an intersection? So an intersection is this, where 2 lines somewhere on the graph, on your graph actually meet. You're looking for where a line crosses those kinds of intersections, something like that, when you don't have a line that hits a nice spot on the y-axis. Well, here's one right here, and here's a second intersection where the line crosses. So now I'm going to count from here to here. So we'll take my slope, and I'll say, well, if I start here, do I go up or down? I go up. How many spaces do I go up to get from there to there? I go up 1 space, so that's a +1. How many spaces then does it take to get over here? If I count my spaces, 1, 2, 3, 4. So this one actually then has a slope of 1/4. Well, let's take a look at it. Let's go back to the starting point. Notice that from the starting point over to just 1 space, it goes up about 1/4 of the square. But to count that, it's easier to count it when I find where the line crosses 2 different intersections, and then I can count whole spaces, which makes the counting much easier. So you will have slopes that will be fractions. This is a +1/4. All right, here's another line that does not cross on an intersection, but on our y-axis, but it has a spot here that it crosses and a spot here that it crosses for an intersection. If I count this now, how many spaces do we count going up? I count 3. 1, 2, 3. How many do I count going over? I count 2. So I say that my slope, m, equals 3 over 2. I counted up 3, counted up 3 spaces, and I went over 2. So slope is 3/2, 3 over 2. Lastly, we have a couple other lines that are different from what we've been looking at. If you have a line that's just flat, doesn't go up, doesn't go down, it just goes flat, and I'm bouncing, never going any further up, never going any further down. Anytime you have that, well, how much do I go up? I don't go up, so what number do we use? We use 0. If you have a line that is horizontal, the slope of that line is always 0, because you're not going up and you're not going down. You're always going right and left. So we just say the slope is 0. Now I have this red line down here. This line is doing nothing but going up and down. Well, when you have a line that's going up and down, we say M is called undefined. And in a future video, you're going to see why we call it undefined. And it will be much clearer as to why we call it that when we actually show you how to calculate the slope. All right, so you have a flat line, always has a slope of 0. There's really no calculating to do. We need to just understand that that is 0. And undefined is just an up and down line. It never moves left and right. So if it doesn't move left or right, we call it undefined. If it only goes, and if it doesn't go up and down, we have a slope of 0. All right, so pick up your assignment on counting slope and take care of that, and be sure to turn it into Mr. Ellenberg when you get done.